All right, now we haven't actually written the prime factorization. We found all the components of it, but we now have to write it out. There's two ways you can write the prime factorization. The first one is without powers. To write it without powers, you simply take all the numbers you circled and write times signs between them. Now, it would be nice if you put them in order from least to greatest, so that's exactly what we're going to do. We've got a 2, a couple of 3s, and a couple of 5s. The other way you can write it is with powers. Okay, and this will save you some writing, especially if a number comes up a bunch of times. It shouldn't. All right. There's only one 2, so I can't do anything with that. But since there's 2 3s, I can change that to times 3 squared. Okay. Since there's 2 5s, I can change that to times 5 squared. That would also be an acceptable prime factorization. Now, if the book doesn't say, then you can do whatever you want. You can do with or without powers, doesn't matter. All right, so let's try 73. Give me two numbers that multiply together to make 73. Don't think too hard on this one.
73 and 1.
73 and 1. There's no other way to make 73. It's just 1 times 73. When you find that to be happening, that means the number is prime. Which, as now you probably guessed, that means that this one, since it actually had other numbers, would be composite. Okay. In the last column, we're talking about monomials. Should be pretty much a new concept. A monomial is a number, variable, or product of a number and one or more variables. A number, variable, or product of a number and one or more variables. What you see in example 5 and 6 are monomials. You can see the one thing that's missing is any operation signs. There's no addition or subtraction signs in there. They won't if they're a monomial. If they do, they're called something else entirely. We're expected to find the prime factorization of these monomials. It's really not too tricky. First one, 12x squared y. We do it in parts. So the first thing we have to do is we're going to break down the 12. And when we break down the 12, we do it the same way we just did. So, you can pick two numbers that make 12. Ashley, what do you got?
2 and 6.
6 and 2. Okay. 2 is a prime number, so I don't have to go any further with it. 6 I can break down one, so 6 breaks down to
3 and 2.
3 and 2. And both of those numbers are prime. So I write that part of the factorization out. With or without powers, doesn't matter to me. So it would be 2 times 2 times 3, or 2 squared times 3. Okay. Then you got to break down the x squared and y. It's not tricky. All you got to do is take anything that's powered and separate it. That's it. So, instead of x squared, that becomes x times x. And y is just going to stay y. And that would be the one without powers. Now, the part that surprises people most often is for the with powers. It's the exact same thing. Times x times y. Either one of those are the prime factorization. Now, the next question a lot of people have is, well, why is that? That doesn't have any powers in it. That's true. But if it had powers in it, it'd be the same thing that was right there. Look at the point. Really not too terribly difficult. All right, so let's try 6 and then we're done. 54 w cubed z to the 4th.
What?
54 w cubed z to the 4th.
Oh, that's a Z.
Alright, so let's start with the 54. Two numbers that make 54. Ashley.
9 and 6.
9 and 6. Fine. We already know from the last problem, yay, that 6 breaks down to 3 and 2. And that gets me to prime numbers. So that one's done. 9, haven't broken that one. Oh, yes, we did. We broke down 9 over here in example 3. 9 broke down as 3 and 3. I already said that's prime. Okay. So we can write that part of the factorization. You could write 2 times 3 times 3 times 3, or 2 times 3 cubed. Remember, it's cubed because there's 3 of them. All right. Now break down the W cubed.
W times W times W.
W times W times W. And remember, it's the same with or without powers. Break down Z to the 4th.
Z times Z times Z times Z.
There you go. Not bad.